So I have a shocking thought for you that data isn't always perfect. Let's pretend it is at first and then see what happens. So let's say we were taking data on someone or a train or something speeding along, and it was going 60 miles an hour and then 50 and then 57 at these time points. We'd say the distance so far at time 0 is 0, and then what would we say for the next time point? Well, we'd copy the 0, or we'd say this equals the previous cell plus, and how far have they gone by time 0? Well, by time 2, you could say, well, maybe they went 60 miles an hour the whole time, maybe they went 50 miles an hour the whole time, maybe average the two. So you could say average of the 60 and the 50. Of course, you would refer to the cells, you wouldn't type the numbers. Times the delta t value. We could have delta t over here, which would be 2 and then 1, times the delta t, and then you do it again here, right? So first of all, I should point out that this needs to be a comma, not a plus or a times written the computer way. We want to tell it to average 50 and 60, and hopefully it should get 55. If you put a plus there, it would do 50 plus 60, get 110, and then say, what's the average of 110? It would think there's only one data point whose value is 110, so it would say the average is 110, and you'd be multiplying by something that's way too big. Or if you multiplied them, then you'd get, what is that, 3,300, something like that. And then it would just give you that number back because it would see it as only one number. So that really does need to be a comma, or in Excel notation, if you're referring to cells, it can be a colon. So it could be a colon to show a range of cells. Like average of like C6 colon C7 would say take everything in that block of cells, add it up, divide by how many cells that is. All right, so anyway, that's a quick Excel tip, and we can do that, that's fine. But now let's say we find out that the speedometer we've been using is miscalibrated. It's actually reading maybe 2.397 miles an hour too slow. What should we do with what happened? So here's two options. We could subtract 2.397 from the final distance. Well, that's one option. We could subtract, oh sorry, too slow, so we should add, right? Add 2.397 to each distance so far. Or we could add 2.397 to each speed that we had. Which of those do you think is the best idea? This one's the least work. You only do it once. You only do one computation. Well, think about units. What would actually work here in terms of units? 2.397 is a miles per hour. Should you add it to a number that's measured in miles? No, you can't add miles per hour to miles. The same thing is true for the second option here. It's the same units problem all over. The third one at least doesn't have that problem. So at least the units work out to add 2.397 to each of these speeds, and then the distances so far should be better, should be more accurate. So we'll say nope to those. and yep, to that one. So what I would do is have like delta t time in hours, original speed data, in miles per hour, and that would have the 60, 50, and 57. And then I would have adjusted speed data, in miles per hour, and that would be 62.397, 52.397, 59.397, etc. And then I'd have the distance so far. So how would you find out that how the speedometer was miscalibrated? Well, maybe you had a calibrated radar gun and you drive past it a few different times and say what was the speedometer reading, what was the radar gun reading. Those might not all be the same, but if you had a bunch of those values, you could take their average, and that would give you kind of the average miscalibration. Oh, I forgot to say here, this distance so far would only use stuff from this column. It wouldn't use this column at all. So it only uses the adjusted speed data. And the delta t values.